Hey everyone, it's Mrs. Gifford here, and today we are going to talk about lesson 06, Linear Inequalities. And so today, after the lesson, you should be able to use algebra to solve linear inequalities. So let's take a look at our examples. So what are inequalities? We have these four symbols. This first one that we have is the greater than symbol. And an example of using this symbol, you would say 7 is greater than 3. Okay, and if you think of it or you need to think of it, you could imagine that the little inequality symbol is like Pac-Man, or Miss Pac-Man in this case, and it wants to eat the big power pellet, so it needs to be open to the larger number. So if this first one is greater than, then the second one is less than. And if we want to use this in an example, we would say negative 10 is less than negative 2. And then the biggest difference between the next two is that you'll see this little half equal sign down below. So this third one is greater than or equal to. That means either can be true. It can either be greater than, the first number can be greater than the second number, or they can be equal to. So an example here, I'll stick with negative 10. Negative 10 is greater than or equal to negative 12. Or we could have put negative 10 is greater than or equal to negative 10. That being the true part would be the negative 10s. So if this third one is greater than or equal to, then this last one is less than or equal to. And the same thing holds for this one. So if I want to have an example here, if I want to say 14 is less than or equal to 14, this is true because I have this additional inequality with the less than or equal to. We could also have said 14 is less than or equal to 15. So let's take a look at solving equations with these inequalities using our algebra skills. So our first one is x minus 17 is greater than 12. So we're just going to think back to how we solved these if there had been an equal sign there instead of the inequality. We're going to work backwards, and so I need to undo this subtracting of 17 by adding 17 to both sides. So in this case, the 17s cancel each other out, and I get x is greater than, and 12 plus 17 is 29. Now what you can do to check this is pick a number that makes that inequality true. So in this case, if I want to check it, I would say, oh, let me put in x is equal to 30. So if I do 30 minus 17, is it really greater than 12? So from here, 30 minus 17 is 13. And yes, 13 is greater than 12. So I know that x is greater than 29 is the proper solution for this problem. So if I go on to our next example, we have t divided by 6 is greater than or equal to 11. And we need to think, what's the opposite of division? It's multiplication. So I'm going to multiply both sides of our inequality by 6 to get rid of that 6 in the denominator. And 11 times 6 is 66. So we are thinking that our solution is greater than or equal to 66. Well, in this case, because we have greater than or equal to, if I want to check it, I can actually pick the number 66, or I could pick something that's greater. I'm going to pick 66, and I'm going to check to see if this really is greater than or equal to 11. 66 divided by 6 is 11. And I know that, oops, that's a check mark, that last one. So I do know that they are equal. So this particular inequality is true. 6, so 11. I'm just fixing that up a little bit. 11. So yes, we're good to go. So let's take a look at the next example. So in this case, we have this big warning, this caution. Just a reminder, if you multiply or divide by a negative number, you're going to flip the inequality symbol. So as we look at this first example, we have negative 5c is greater than 30. And so when we see a number next to a variable, it means to multiply. So to undo that multiplication, we're going to divide. And again, because we have this negative number here, we actually need to flip that inequality. So I'm going to do that right now and bring it down. Instead of it being a greater than symbol, I need it to be a less than symbol. So from here, we're going to finish this problem exactly as we would usually. My negative 5's cancel, and that leaves me with c is less than, and 30 divided by negative 5 is negative 6. Now in the previous screen, I showed you how you can check your answers. So let's check this. Let's pick a number that's smaller than negative 6. I'm just going to pick negative 5. And I'm going to check to see if negative 5 times negative 7 really is greater than 30. So a negative times a negative is a positive, and 5 times 7 is 35. So is that inequality true? Yes, it is. So we know that c is less than negative 6 is the correct answer to this inequality. So our next one, we have this particular problem with variables on both sides. So we have 4z plus 7 is greater than or equal to 8z minus 1. Now there's all sorts of things that we can do with this particular problem in order to solve for this variable. And the big key here is to make sure whatever you do to one side to do to the other. So I'm going to solve this, and I'm going to choose to subtract 7 from both sides to get that 4z by itself on the left-hand side. So in this case, in doing so, the 7's cancel. I have 4z on the left is greater than or equal to 8z. And when you subtract a positive, it's the same as adding a negative. So negative 1 plus negative 7 is negative 8. And now because all we have is z on the left-hand side, I need to do something with 8z. Because it's positive, I'm going to subtract 8z from both sides. And 4z minus 8z is negative 4z. I haven't done any dividing or multiplying by a negative, so I keep the inequality the same. And I bring down my negative 8 because my 8z's cancel. Last step, I need to divide by negative 4, both sides. And here's that warning, because this is negative, we're going to take that inequality and switch it from being a greater than or equal to a less than or equal to. And I get z is less than or equal to positive 2. So in this case, again, to check it, you can pick something that's either equal to 2, which is 2, or you can pick something that's smaller than it. And I'm actually just going to pick z equal to 0. So I'm going to check to see if 4 times 0 plus 7 is greater than or equal to 8 times 0 minus 1. Using the order of operations that we talked about previously, we're going to multiply first. 4 times 0 is 0. 8 times 0 is 0. 0 plus 7 is 7. And 0 minus 1 is negative 1. 7 is greater than or equal to negative 1. So then we know that z is less than or equal to 2 is the solution to this particular problem. There you have it, folks. Now you have a refresher as to how to use your algebra to solve inequalities.